Today we're going to look at doing file access, but this time using the Common Language Runtime and the Dotnet framework. The Dotnet framework is a software framework and API or application programming interface that provides many advanced features for Windows applications. All .NET applications run through the Common Language Runtime or CLR. The .NET framework allows itself to be used with multiple programming languages such as C++, Java, C#, and Visual Basic. It does not provide true platform independence, but does allow interoperability between different programming languages. The Common Language Runtime, or CLR, is a virtual machine or VM that operates much like Java's VM. However, unlike Java, which is platform independent, the CLR only works with Windows applications that implement the .NET framework. The CLR functions as a JIT, just-in-time compiler, and handles things like memory management, exception handling, and type safety automatically. It also implements garbage collection like Java, automatically cleaning up and removing unused objects from memory. So we're going to create a simple console-based project. Let's go to File, New Project, and we're going to choose a Win32 console application, and we'll just call this CLR1 for Common Language Runtime. I'm going to go to Application Settings, choose Empty Project, and click on Finished. Now I need to add a source file, so we're going to add a CPP source file. And this is our first project with the Common Language Runtime, so we'll call it CLR1, or whatever you want to call it. To create an application in Visual Studio that uses the CLR and .NET framework, right-click on the project properties and select Configuration Properties General, Common Language Runtime Support, and then select Common Language Runtime Support or /CLR. And now I need to go and right-click on my project and go to Properties. And in the same way we would, set up projects that use the MFC to use the MFC in a shared DLL or in a static library. Remember doing that up here? Well, we need to specify .NET applications use the Common Language Runtime. So we have to come down here, and we need to select Common Language Runtime Support right there, okay? And we'll put that into the project there. Now, in the interest of keeping this brief, I've already pre-coded this project. So I'm just going to step through the code, but I wanted to show you how to create a project, a .NET or Common Language Runtime project from scratch. So let's look at the differences from how we've been doing standard ASCII File Access. Note that for this project we are not using the standard namespace. Instead, we are using namespace system and namespace system IO. First off, instead of using the standard namespace, we're using system and system IO. Alright, so we'll want to implement this. Next are our globals. Use the keyword const to declare a variable as a constant in C++. This is useful when you need a value that cannot be changed, such as a value dealing with the size of an array, which also cannot be changed. You can compare this to the keyword final in Java. In C++, you can create a series of constants that can be automatically assigned values and consolidated into a single statement of code. This structure is known as an enumerated constant. Here's an example. The code above is the same as declaring each and every single one of those as a constant integer with a unique value. We have a constant, in this case this is the maximum size of our database, and we're going to use it to construct an array, and we'll use the array to store our records, our information. It's sort of like using the final keyword in Java. Now we have another integer in this case, and it's called record count. And we'll use this to index the subscript value of our array. And finally we have an array of doubles that's not built on the stack this time, but built on the heap, or the free store. So remember, anything you build on the heap, or the free store, is accessed via a pointer. Now we have our function prototypes. Main menu, pause, enter data, some basic read and write functions, and then some functions to just sort and display the data. And then finally, just to make a point, basically I wanted to demonstrate here that you could prototype a function to take an array, but then you could take a pointer to an object of that same type, a pointer to a double, and you would be able to access the entire array. And the reason is, remember, when you access the name of an array, the array's name is a pointer to the entire array, all the objects, all the elements stored in it. Remember, the name of an array acts as a pointer to the entire array structure and all of its elements. By passing only an array's name into a function, you give that function the ability to access all of the array's elements by reference. So just having the array's name via a pointer, I can access all of those elements. And we'll examine that or take a look at that. So we come down to main, and what's the very first thing that happens in main? We call main menu. Alright, and then when we're done, just a standard code to exit the program. And I wrote a little function here to pause, sort of like the system pause in standard ANSI C++. Okay, so let's take a look at that real quick. All pause does is call console readline, and it beeps. That'll cause the cursor to blink. It'll wait for the player or the user to just hit the enter key, and then it'll move on. CLR note number 1. When displaying data to the console, the CLR uses console write line instead of cout and the datastream operators, as we have done with standard ANSI C++ in the past. In appearance, it is similar to Java's system out println method. In syntax, the console write method functions like a step back into the old C language's printf function. For example, suppose we had an integer x and it had a value of 10, and we wanted to write it to the console. We would use the method console write and the string literal the value of x is. Then in curly braces, we'd add 0 since it's the first object that we're converting, and we'd have to use a conversion method such as convert to string to convert the integer data type to a string data type. All of this would then be concatenated and sent to the console. The .NET console write method does not cast, convert, and concatenate the way the datastream operator does in ANSI C++. Instead, you use conversion functions like convert to string to convert data from a non-string data type to string data. Unlike cout and the stream operators that we were doing with ANSI, notice that we're using console write line. And you'll notice a lot of similarities between the programs that use .NET and the common language runtime in Java. Java would say system out print or print line, and a CLR console application says console and then write line, 2 colons to resolve the scope. Okay, so there's our main function. That's the only function that runs automatically. Now that brings us to main menu. And main menu is just a typical menu. Like in any console program, there's 3 basic parts. It's going to be inside of a while true loop. There's going to be a sentinel value. And inside the while true loop, the 3 basic parts are A, we present the menu choices. And again, that's using console write line since it's the common language runtime or .NET instead of cout and the stream operator. The next thing we do, B, is we have to take input from the player or the user to figure out what they want to do. And then finally, the third part, C, we have to process that information. So it's just a switch statement usually, although you could also use if and else. And so based on what they decide, we'll go call the appropriate function. Again, up here, we could have used a single character, but the problem is if they were to type out more than 1 character, say they were going to type the whole word, it would overflow, the size of that 1 byte character, and that would cause lots of problems. Worst case scenario, depending on how, what you're doing, it could crash your program. Best case scenario, it's going to loop unnecessarily and confuse the user or the player. It may go on to the next, statement or the next decision process in your code. So by using a string instead of a single character, then we can handle that, okay? We can bulletproof it a little or make our program a little more forgiving. And then the next thing we're going to do is convert everything to lowercase, like we have been. That way it doesn't matter whether they type capital or lowercase. Now when we switch, we can't switch on an entire string, but we can switch on a single character, and that's fine. That's what we want. We're not interested in everything that comes after these characters, just the very first character. But by using a string, we can handle it if they do type more than a single character. Okay? Unlike Java, where there is one string class object that can be used everywhere in the Java language, in C++ there are many different types of strings, and each type of string can only be used in certain circumstances and situations. For example, here are examples of some different types of C++ strings. There is an array of type character string, there's a pointer string, there's a standard string without the string.h header file, there's another kind of string when you include the string h header file, there's a C string, and then there are also MFC string objects like lpctstr string. As if those weren't enough kinds of strings, we're going to use yet another type of string in C++. In this case, a .NET CLR managed string, with a capital S rather than a lowercase s, and a caret. The CLR caret functions like the ANSI asterisk when setting up a pointer to an object. The key difference is that the string caret x creates a managed string object in .NET where garbage collection will automatically free memory once the object is no longer being used or falls out of scope. Now, one of the key differences, you'll notice the caret here instead of the asterisk. In ANSI C++, when you create a pointer to something, you use the asterisk. But when you're using the Common Language Runtime or .NET, you use the caret to create a managed reference to an object. So this is essentially the same thing as a pointer, or works just like a pointer, but the caret denotes that it's a managed object, so you don't have to worry about calling delete on it. The .NET Framework garbage collection process will handle that automatically for you. Sounds like Java? Yeah, me too. I kind of think the same. And remember, Java does that. Java automatically cleans up objects when you're done with them. Well, by utilizing the caret instead of the asterisk, and declaring this to be a reference, a managed object in the Common Language Runtime in .NET, it too will receive the benefits of garbage collection, and things will automatically be tidied up and cleaned up when we're done with it. But when you see that in .NET projects, remember, just think of that as a pointer. Okay, so that's just our main menu anyway, and respectively when the player or the user decides, we'll call read data, write data, enter data, display data, or any of these functions down here. And we'll just go through those one by one. Before we write to and read from a file, let's examine the function enter data. Already talked about main menu and pause. The first function we'll look at is enter data. And this doesn't really implement file access yet, or write to a file or read from a file. Essentially, it's just there to allow the user or the player to input information into the subscript values on the array, in the array that we've created. So we're going to use a boolean here, bool legitimate number, and it'll start out to be true. And we're going to use this in a little bit of bulletproofing, just in case they type in a non-numerical value. We want to be able to catch that, otherwise bad things could happen. Now, record count, it's a global, but we're going to reset it in any operation that has to deal with editing, reading from or writing to the database, because it's going to be used to access the subscript values of our array. And again, this is just a managed reference to an object, or you can think of it as the Common Language Runtime or .NET version of a pointer. All right, so there's a pointer to a string there. CLR note number 2. System Console Clr is a CLR version of ANSI C++'s System CLS. This is equivalent to the ANSI, System CLS. So we're calling System Console Clr. That'll clear the console screen. Readline, console Readline. Think of that like the Java system out print or print line. But we're just displaying a line of text on the console. And then right here we have a basic for loop. Okay. All the way, the rest of the function is pretty much a for loop. So let's take a look at that. We start at 0, the first element in the array. While x is less than max size, that's the maximum size of the array, we're going to postfix increment x, okay? And we're going to enter some values here. So the way that write and writeline work, it's kind of like the old C printf. We had scanf and printf. It's a little bit different. You don't use the stream operator, and it doesn't work with an overloaded addition operator like Java's print or print line. But if you've done any projects in the old C language, that's much what it's like, the old printf command. So any variable that we're going to display along with the string literal, when we concatenate, then it would go inside the curly braces here. Okay, and the 0 is just saying, take this object here, the very first object that I've converted, and these curly braces display that. And so what are we doing? Well, x is an integer value, it's not a string. So in order to concatenate it with this string, we have to call convert to string, we pass it in, and then we display it here, along with the string literal. Now personally, I like the way that either Java does it, or I like the way that standard ANSI does it. When you're using the standard namespace, and the stream operator can just seamlessly kind of convert all those things. But some people prefer this method. So if you see this in code, just understand that's how that works. Or what's going on is concatenation. You're taking an object of a different data type, in this case an integer, and you're concatenating it and displaying it all as part of the string. So as x increases, then that will be displayed and printed as it's converted to a string in this statement right here. Okay?
CLR note number 3. Console readline is a CLR version of ANSI C++'s cin or cnignore and getline cin string method combination for getting an entire line of text.
Next thing we're going to do is call console readline. And if you're used to Java, then you can think of that almost like a scanner object or a line number reader object. Next line or readline, the function is even the same name, although it would be a lowercase r. But this would be equivalent if you're used to ANSI C++, that would be equivalent to cin, console in. Sans the stream operator, of course. That's just going to return a string, so the cursor will blink. It'll wait for the user, the player, to type something in the console. When it does and it comes in, it will be stored inside the string data. Okay? Next is a little bit of bulletproofing. Let's check and make sure that data is not empty. If it is, we'll set it to be a non-meaningful, invalid space value. But that's better than nothing or null, because otherwise we could have problems later on. Like if we were to call to lower or utilize other functions on a string that's a null object, we want to be careful. So that's all we're doing there. And then
CLR note number 4. The to lower method converts an entire CLR string to lowercase, unlike the ANSI C++ to lower function, which only converts a single character. This doesn't mean we can't do this with ANSI C++, it just means we have to use the to lower method inside of a for loop. So let's say we had a string convert me, and it was supercalifragilistic. If I wanted to convert the whole string to lowercase, I'd simply put it inside of a for loop and do it character by character at a time.
Here we're just converting it to lowercase. And instead of the dot operator, we need to use the arrow because it's a reference, there's indirection here. And we have to kind of resolve that. And in this case, even though data is a managed, object, it works just like a pointer. A pointer that implements garbage collection. So just like anything that's we'd access on the heap or the free store or anything via a pointer, we need to use the arrow and not the dot operator. But that we call the to lower function that converts it to lowercase. Okay. Next, if the first element, in this case that they've entered is Q or quit, then we're going to break out of the for loop. And we want to do that first. There's no need to process anything else or make any other decisions if they've chosen to quit. That would just be wasting time. So if they've chosen to quit, we'll break out. But if they have not chosen to quit, then and only then will we continue to process things. So then in the else portion, they have not chosen to quit. Hopefully they entered a number. We need to go through.
The CLR managed string, with the carrot, length method is like ANSI C++'s getLength method on a string. It returns the size of the string. In other words, it renders the exact number of characters in the string.
And we're just going to take a look at this string, and we're going to use the length attribute, which we don't know how big the string is, but that's dynamic. That'll automatically give us the number of characters in the string. So for every character in the string, we're going to test it.
The system_is_number method is like ANSI C++'s isDigit function. It returns true if the character is numerical and false if it is not.
And we're going to say, look, system char is number. It's sort of like the old standard ANSI C++ isDigit, okay? Or catching a number format exception in Java, but we're going to say is number. And if it's not, if it's false, if it's not a number, legitimate number is going to be set to false. Now remember up here it was set to true. So if everything's hunky-dory and what they've typed in is, they're all legitimate numbers, then legitimate number will never be set to false. It will remain true. But if they type in any funniness, characters that are not numbers, it will be set to false, okay? And so then by the time we get down here, we've checked to make sure that all things were valid numbers, and if legitimate number is still true, then it was a number. If legitimate number got set to false, it was not, so we want to skip this. And we'll simply say, hey, that was not a number. We'll decrement x. In other words, we're going to move them back, or defeat, or undo, the increment of x that we did up here, so they can, again, enter the first element, or whatever element they were on when they entered some non-numerical value. If it was numerical and legitimate number is true and everything is good, then we want to take what they type and we have to convert it. And the thing is, what they enter in comes into us as string data. It's always string data. But what the array needs is a double. So we have to convert. You can think of these functions in .NET or the Common Language Runtime as the parse functions in Java. Integer parse int, double parse double, and so forth. So we have to convert the data type from a string to the appropriate data type, which is a double, so we call convert to double, passing in the string, and that gets stored in each subsequent element of the array, indexed by the subscript value. And finally here, record count, we're just going to increment record count, and that will take care of updating the subscript value on the array, and that will also, it acts as an accumulator. It lets us keep track of the records. We need to know how many records we have when we do read and write processes. And finally, when we get down to the bottom here, we call pause, and that'll wait until the user hits the enter key. And then everything here works off of or from the main menu, so that would just go back to the main menu, which will clear the screen, and then we can move on to the next function.
Now let's examine display data.
Let's go look at the next important function, which is display data. And once we enter the data and store the doubles in an array, how do we display the doubles and the values? So if the player, the user, enters D, it just calls the function display data. So let's go find display data. And display data is pretty straightforward. It just clears the screen with system console clear. We're going to console write line and display this text in the console. We have a simple for loop here, and the idea is we're going to use record count, and this just maintains the number of valid records stored in the array. Elements in the array or objects in the array to actually store a double. And we're just going to go through that, and we're doing some concatenation. Remember, this is kind of the funky, interesting way that the Common Language Runtime or CLR implements concatenation. So again, if you were in Java, you'd say system out print or print line, and you'd have your string literal here, and then you could use the overloaded addition operator and just pass in an integer. But in this case, it's not. If this were ANSI C++, you could use the stream operator, and the stream would just concatenate a string literal to an integer. But here we have to use the function convert to string, pass that in, and then in these curly braces here, this is where the converted value here would be displayed once it's concatenated and added into this string, this character array. Okay, so we do that. And then in this case, value and element, and let's hypothetically say we're going through the array the first time. Alright, so value and element 0 is, and then we're going to convert whatever the value stored in that is. So value of element is, and then we're going to add a space, and then we're going to display the value stored in the array, whatever that number might be. And then we just have two lines with dashes here, and we're calling pause. So once we've entered the data and populated the array with doubles, and once we've coded the ability to display it and go through the array, we'll need the ability to save it to a file and then read it back from the file. And that's where these top two menu choices will come in, read and write. And respectively in the switch statement, they call read data and write data. Well, let's see how we write it, and then we'll see how we read it. Here's an overview of writing to a file sequentially, CLR style. First, declare a managed instance of StreamWriter with the caret. Second, create a try and catch block for an IO exception. Third, build a managed instance of StreamWriter in the try block with gcnew. Fourth, write data to the file with a delimiter such as a line. And finally, close the StreamWriter object when writing is complete. When the data you are writing to the file is not in the format of a string, you will need to convert it before writing it with the convert to string method. Example, let's say that I have a double. If I want to write a double, I have to use the convert to string method to convert it to a string and then write it. we have to create the file and write to it first. So we'll look at write data. Now once again, this is sort of the .NET or Common Language Runtime method of implementing a pointer. But the caret denotes that it's a CLR managed object, so pretty much like a reference or an alias. But essentially, we can use it as a pointer. I guess you could probably argue both sides if you wanted to get into semantics, but let's paraphrase it a little bit or generalize and say that this is just sort of the Common Language Runtime method or .NET method of implementing a pointer, but a pointer as a managed object. In other words, a pointer that you don't have to call delete on because it implements its own garbage collection process, just like objects do in Java. Okay, the next thing we have is a Boolean, just true or false, and we're going to use this to do a little bit of bulletproofing to see whether or not we successfully can open the file and write to it. Otherwise, if we can't open the file, we don't want to try to loop and go through the array and write things. And then here's another managed object. Again, essentially, we'll call it a .NET pointer. Okay, so a pointer to a string, a pointer to a stream writer object. Now this stream writer object, we've discussed file access, different kinds of sequential file access, random file access, binary file access in Java, and we've looked at sequential and binary file access in ANSI C++, sort of the standard C++. And that works with the fstream header file and instances of ifstream and ofstream. But this is a little bit different, okay? Instead of implementing that, here we're going to implement a stream writer object. So output file will be the pointer that points to an instance of a stream writer object. And we'll implement or we'll use that in the same way that we would use an ofstream object from the fstream header file. Okay, so sort of the .NET way of doing it. And we're just going to clear the console. We're going to tell the player what we're doing, the user, hey, we're attempting to write some data. Now, like any I/O process, we need to enclose it in try and catch blocks. So this whole process here of opening the file is going to be inside of a try block. And all right, we're going to go through and we're going to use the command instead of new, gcnew, because again, this is a .NET managed object, right? Remember the caret? So it implements its own garbage collection. So as opposed to the keyword new, which we would use in ANSI standard C++, we're going to use gcnew, which we implement in .NET. And so therefore, StreamWriter is instantiated as a managed object, and it's going to call the file number_data.txt. We'll display on the console file created if everything's okay, and we'll set our boolean to be true if everything's okay. And if something went wrong, let's say that we didn't have permission, we didn't have space, couldn't find the drive, couldn't, for some reason, couldn't create the file, then it'll go to the catch block, we'll catch an I/O exception, and in this case, we're just going to display a stack trace, whatever message was from the console after we displayed couldn't create the file. Okay, if everything is hunky-dory and copacetic and we could create the file, the boolean was set to true, and so then we're going to implement this inside of an if block. So we're going to tell the player or the user, hey, we're writing data to the file, we're going to have a for loop, and this is going to be record count. Now record count was ordered or numbered, it kept count, it was used as an accumulator in the data entry function of our little database here. So it's kept count of the total number of records that we need to write to the file. And also if we were to read data from a file, it would also be used to keep count. So we don't want to reset record count in this function like we do in other functions, where we would be like re-indexing the array. So we need this. So let's hypothetically say that we entered in 20 records, okay? Record count then therefore has a value of 20. And so for 20 times while x is less than 20, we're going to take our output file, which remember that's our pointer that points to an instance of the stream writer class. We're going to use the arrow because it's indirect, it's a pointer. We're going to call the method writeLine, okay? And again, remember, you can compare this. This is sort of like calling print line on a buffered, or on a print stream object in Java, excuse me. Or you could think of it like, after you call the open method, you can then turn around and stream data with the stream operator in ANSI C++ once you build an instance of ofstream. So you can compare it to things we've already talked about or already looked at. It's just a different way of doing it, okay? So this is sort of the CLR.NET way of doing it. So output file writeLine, and we're going to convert to a string. We've got to do some parsing, some conversion here. And we want to take our double. Remember that it's an array of doubles. It's not an array of strings, so we do have to convert it. But all we have to do is pass it in as an argument parameter to string. We convert to string, and then we can write that out to the file. Now, if we weren't using writeLine, we'd have to add like a escape sequence, like a \n as a delimiter and a string literal. But
we don't have to worry about that because Readline will simply use, it'll write a whole line and it'll move the file pointer down like a carriage return or a line feed to the next line. So the next time we iterate through the for loop and we write again, it'll be on a new line. And so in this way, the lines and the file become delimiters, okay? And then if everything is hunky-dory and copacetic, then we'll simply say all done success and we'll close our file and we'll just pause and wait for the user or the player to do something. All they have to do is hit the enter key to move back to the main menu. So they move back to the main menu, and let's say after they have written to the file, then they want to read from the file. Okay, well let's look at that. Here's a brief overview of reading from a file sequentially, CLR style. First, declare a managed instance of stream reader with the caret. Second, create a try and catch block for an IO exception. Third, build a managed instance of stream reader in the try block with the keyword gcnew. Fourth, read the data from the file with the method readline. And finally, when you're done, close the stream reader object when reading is complete. All data read from the file using the readline method is string data. You must explicitly convert this data to non-string data types when necessary by calling the appropriate convert method, just like using Java's parse methods. For example, let's say we have a double called x. If I want to read data from the file and store it in the double called x with sequential file access, then I have to use the function convert to double, and in parentheses as a parameter I would pass an input file readline to read data from the file as string data and then convert it to a double so I can store it in x. To read through an entire file until the file pointer reaches the end, you can use the peek method. This functions much like the ANSI end of file or EOF method. It returns -1 when it reaches the end of the file. For example, if we have a string, a managed object called x, we would put it inside of a while true loop, and we would call the method readline until peek returns the value -1, indicating the end of the file. That would be the sentinel value. Okay, here we had a stream writer when we were writing to the file. Now we have a stream reader. But the process is very similar. There's the caret, so you know that it works like a pointer, but it's actually a .NET managed object. And because it's a .NET managed object, we have to use gcnew down here, so it implements its own garbage collection. Now, in this example, we are resetting record count. Now, when we wrote to the file, we didn't want to do that because we needed to maintain the value of record count to write the correct number of lines, or correct number of values in the array. But when we read it from the file, here we want to reset record count because we don't know, it's dynamic. It's not determined until runtime, exactly how many records might be in that file. So we will reset it here. But we have a boolean for bulletproofing, kind of like we did before. Clear the screen, display on the console attempting to read data. Just like we did when we wrote, it needs to be in try and catch blocks. It's an IO process. We'll try to open the file, and this time with our pointer to our stream reader object, input file, we'll use gcnew. It's a managed object, and again we need to make sure the name is the same, number_data.txt. If it's okay and everything went well, we'll display found the file and the boolean is set to true. Otherwise, we fall down to the catch block, we catch an IO exception. We have a situation here, the error is we do a stack trace, display what it is, and the boolean is set to false. If and only if everything went okay and the boolean was true, we'll display opening file and reading. And this is a bit different, whereas when we wrote the file, it was based on the number of records. This is a more uncertain or dynamic situation, potentially volatile situation, because we don't know necessarily how many records are going to be in the data file, in the text file that we open for sequential access. So instead of implementing record count, which we don't know, what we can do is we can just go to the end of the file. Since we're using a line as a delimiter, we'll just go to the, until the file pointer reaches the very end of the file. And that's what we're doing here with our stream reader object. We're saying input file peek, while it's not equal to -1. Well, -1 essentially is, EOF, like the EOF function in ANSI C++, that returns a Boolean value, true or false, whether or not it's at the end of a file. Well, for all intents, if it's not -1, it has not yet reached the end of the file. When it becomes -1, it'll reach the end of the file. And record count is less than max size, and this is simply because the size of our array was set to max size. We don't want to exceed max size. So, remember the and says both have to be true? So that means if either one of these happens, it's enough to break out of the while true loop. So either we reach the end of the file, we'll break out of the while true loop, or we'll exceed max size and we'll break out of the while true loop. And that's what we want. Okay, so no more than 100 records. But All right, so we'll read to the end of the file. We're not sure. Let's say there are 39 records. All right, there'll be 39 lines, 39 doubles stored in the file. We'll read to the end of it. How do we do that? Well, here's our array, and the subscript value or the index value is going to be based on record count. Okay. Now remember that record count up here was reset, so it's going to start out at 0. Okay. So record count starts out at 0. We're converting to a double. What are we converting to a double? Well, all of our data comes in as string data. This is sequential file access. We're using a stream reader that was, previously written. The data was written with a stream writer. So it's all string data, ASCII data, Unicode ASCII data in the file. It's not binary. So it comes into us as a string. So as an argument, if that returns a string, we have to convert all of that to a double, and that's passed in as a parameter to convert to double. And then that, once it's converted to a double, would then be stored as an element in an array of doubles. And we can do that because remember that an array can only hold objects of one data type. Okay, and so it has to be a double. It couldn't be any other kind of object. Okay, well, after we do that, we're just going to display a little bit of feedback. Remember how this works? We're just concatenating. So right here, this denotes where we're going to display the return value, what gets converted when we convert the integer record count into a string. First time through, that's going to be what? 0. So it would say value of subscript 0, and then it would actually show us the value that's stored there, because the next line, we're doing it again, but this time the argument or the parameter being passed in is not record count, but it's the double stored at, in our example here, the first element of array of doubles, all right, until we increment record count and go 1, 2, 3, 4, 5, and so on to the last one. Okay, and then finally down at the bottom, that's all we're doing here. There's a postfix increment on record count. So we will do that, and when we read it all in, we will, populate the array, element by element, line by line from the file, and when we're all done, either we've reached the end of the file, and -1 was returned, or we've exceeded the maximum, record size, the size of the array. Either way, we'll close the file, and we'll simply say closing file, all done, success. We'll display a little bit of feedback, and we'll pause and wait for the player to do something. So why don't we test that? Let's test the write process and the read process real quick. Testing 1, 2, 3. So let's test it out. If we open the Visual Studio project folder, notice that there's no data file there. No text file has been created. So let's run it, and we will enter some data, and then we'll display, see what's in the array. Then we will save some data. We'll close the program, then we'll open it again, and we'll read the data from a file to test everything out and just kind of see how it works. Alright, so if I were to display the array now, there's nothing in the array, right? Haven't put any data in there, so let's go ahead and put some data in there. And to do that, I need to call the inner function, and we'll populate the array with some doubles. So let's say, our first ever Pac-Man score was 100, and then they got better in 1,000, and then 15,000, and 20,000, and 25,000, and we'll do 30, and let's do 31,000, and 31,500. How about that, right? And then we'll quit. All right. So now we have some values stored on our array. So if I call display data now, look. Remember now the arrays start at 0, not at 1. So, yes, we do have 8 elements, but it's not numbered 1 through 8. It's numbered 0 through 7. So element 0 through 7, and here are our values respectively populated, stored on our array. There's our doubles. All right, so I'm going to hit enter. Now let's generate the file. Again, notice that there's no data file here. So watch what happens when we call the write function. All right, so we're going to use our stream writer, and I'm going to call the function and attempting to write data, file created, writing data to file, all done, success. Okay, so the catch was not executed. We know that everything went okay in the try block. So we'll go back to the main menu. Let's go and look in the project directory. Now here's our data file. It got created. There's number_data.txt. Let's open it, and here's our values. All right, they've been written to the file, streamed to the file via the stream writer sequentially or as ASCII or Unicode text. So I'm going to go ahead and quit, exit the program, and we're going to run the program again.
And when we run the program again, this time I'm going to display the contents of the array. Notice that since we quit, all that data was free, the memory was released as objects were destroyed. Nothing's in the array now. It's completely empty. So let's see if we can read the data from the file. So I'm going to call the read data function now. And opening the file, and here, it's moving the file pointer down the file line by line, 8 lines total, so 0 through 7, and storing each object in the array. Remember that data comes in as string data, so then it has to be converted to a double, and then it's stored in the array of doubles. So I'll press enter, and now if I were to call the function display data, notice that everything has been successfully stored in the array. Alright, so again, there's our 8 squares, our 8 elements, doubles, but it's indexed 0 through 7. So I'll just kind of give you, hopefully, not a too convoluted or lengthy tutorial or an overview of file access using the Common Language Runtime and .NET.
Sorting the data.
Now that we've looked at methods of entering data and populating an array, displaying that data in a for loop, writing that data to a file, and reading that data back from the file, let's look at methods of sorting the data. And so we're going to examine these options, total, average, high, and low, with these menu choices up here real quick as far as sorting the data. So let's go down to our first function. Let's see, way down under display data, we'll go under display total. And all we have to do, once we either read the data or enter the data, and the array is populated with doubles. The neat thing about arrays is you can do so much with them when you combine an array with a repetition structure like a for loop or while true loop. So we're going to basically declare total here as an accumulator. It's a double. We're going to loop through every element in the array, as defined by record count, the number of valid records in the array. And we're just going to accumulate that value. So in other words, total is equal to total plus whatever that value is. It's just acting as a standard accumulator. We're going to come down here and display the results, and again, we're just concatenating, we're converting it to a string, and it would be displayed here with the symbol, and adding a line. So we'll do something similar with average. We'll add all the values up in a for loop, and then of course we're just going to divide that by the number of records, and that would give us the average once we convert it to a string and concatenate it, and it would be displayed right there, within that string literal. Display high, we're just going to go through and we're going to loop, and as we go through the loop, high starts out, it's just 0, has a default value of 0. But if it's less than an array of doubles, then we're going to display it's higher, and we're going to take whatever that is. If high is less, then that means high is higher. And obviously it couldn't be the first time, it's 0. But if it is, we're going to swap it. So then high will become high, and then we're going to go through and, basically once we've gone through all of the, elements in the array, whatever's left when we're done, that will be the highest number because of this test here. Is high less than, otherwise do this. And then finally we're going to display it here. We'll concatenate it and add it to the string. And then the last thing we're going to do is display low, and we're just doing the opposite. We have a variable called low here, and if it's greater than low, in this case we'll do nothing, but if it's not greater than low, and then we'll take it and we'll store it inside the variable low, and we'll display it, okay? So, when we're all done, we're going to concatenate it to the string and display it. So let's test that out real quick. We'll run the program. And I'm going to go through, and there's nothing in the array at this point, so let's read the data from a file. If I call display data, nothing's there. So let's read it from a file. Alright, we read it from the file. There's our data. And I'm going to press enter to continue. And let's try our function. So let's look at the total data values. Alright, and it's 153,600 is our total. And now let's take a look at the average. Alright, so we'll calculate the average there. 19,200 is the average. And let's find the highest. 31,500 was the highest. Let's find the lowest. Alright, and 100 was the lowest.
Making a point. Passing the name of an array to a function is equivalent to passing a pointer to the entire array structure.
And the last thing I want to do is just, kind of make a point. We've talked about it before, but now I want to illustrate it in this little project. The name of an array is a pointer to the entire array structure itself. So therefore, a pointer, or just using the name of the array, can be used to access the entire collection of objects or elements stored within the array. So notice here we have a function that's prototyped, just to make a point here. And it takes an array of doubles called an array. All right, that's the way that it is prototyped. And let's look at the way that we call it. When we call the function, we pass in the array name array of doubles. Okay, that's passed into the function. Now let's look at how it's defined. If we come down here, the way that it's defined, not as a function that takes an array, but as a function that just takes a pointer to a double. Now remember, arrays can only hold objects of one type, or one specific data type. And in this case, this array was declared to hold objects of type double. If you look up here, array of doubles holds an object of type double. Okay? So even though we're taking an array, here's the thing. And this is a pointer to an array built on the heap, actually. But because of that, we can come down here and just using one pointer to a double, in passing in, not a subscript value, but the actual array name itself, we can access the entire array via n direction, or via a pointer. And so we're going to run the function, and it's just going to do the same thing that the original display data function did, this function up here. However, this function was accessing the global, and this function will be accepting an argument just as a pointer to a double. But essentially, it will do the same thing, and I'm just, just to make a point, I just want to show you. So let's go ahead and call it. We'll input j, and nothing's there. Now we're going to read the data from the file. That reads it from the file, so now the array is populated. So if I were to call display data, there's the values on the global, right? Now let's enter j, and there's the values, okay? And this is just, I just put in here a little, this function was prototyped to take an array of doubles argument. However, it was defined to take a pointer to a double argument. And it just illustrates the principle that a pointer to the name of an array can be used to access the contents of an entire array. And that's what we did. Again, if we look at the code, come down here, and this is what we've done here. All right, so we've taken this, which is just a pointer to a single double, and we've utilized it to access an entire array of values that were built up here on the heap, simply because the name of that array is actually a pointer to the entire array itself. And that's all we passed in here.